exam. The screen visible?
Yes, sir.
Yes, sir.
So the physiology of neuromuscular is the first part of the question is physiology of neuromuscular transmission. So it is the same for all skeletal, smooth, and cardiac muscles, more or less the same pattern. And there are three components in that: the presynaptic motor nerve ending, the postsynaptic muscle plate or end plate, and the cleft in between that. So these three components make the neuromuscular junction as it is. So this picture tells you this is the presynaptic nerve ending, this is the postsynaptic motor end plate, and this is the synaptic cleft. The various parts are there. And all of you are familiar with how the action potential has to come here. Once the action potential reaches, the first step is for the calcium to enter this presynaptic terminal from the extracellular space, and then attach it to the vesicles which are already filled with acetylcholine with the help of a protein called nervin, and then bring it to the surface here, break it, and release the acetylcholine. And this acetylcholine has to come and occupy the motor end plate nicotinic acetylcholine receptors to open the channel for sodium to enter again from the extracellular space into the muscle, and then that transmission will send across, and muscle fiber actin myosin complex will be activated to cause the contraction. And this is a very simplified diagram which you can easily draw in your exam. So this is the axon, the mitochondria, synaptic vesicles, and the receptors. And once the action of acetylcholine is over, it is broken down by the acetylcholine esterase which are present in the synaptic cleft. So the trough of this synaptic cleft. And so this is how the acetylcholine is synthesized. To have just an idea, you don't have to write in detail about all these things, and you can just say acetylcholine is formed in the presynaptic area and then stored in the vesicles. And this is a written explanation of how the impulse comes and how the calcium enters, whatever I told you. So the calcium interacts with the snare proteins, which stimulates the synaptic vesicle to fuse with the active zones and release their content. And this is the travels through the cleft to reach the acetylcholine receptors. So this is another diagram to show all these features, how it is happening, and the postsynaptic potential and membrane, and ligand-gated channels, and how they are going to all these areas. And this is the motor end plate that has to be stimulated. So once the action potential activates that, the actin myosin complex has to form this. So in the exam, if you want to write it faster, you can say motor nerve fiber which gets the action potential, comes to the axon terminal, opening of voltage gated calcium channel, entry of calcium from extracellular space into the axon terminal, opening of vesicles and release of acetylcholine. This is what is happening in the presynaptic area. Then acetylcholine traverses through the synaptic cleft, comes and binds to the acetylcholine receptor, opens ligand-gated sodium channel, entry of sodium from ECF, development of end plate potential, which goes to minus 60 millivolts. Then in the muscle fiber, generation of action potential, excitation, contraction, coupling, muscle contraction. So this is a very simplified way of writing it in your exam answers. And the monitoring advantages of neuromuscular monitoring, of course, this is just for knowledge. You may not write all these things. If they just ask you modes of monitoring the neuromuscular function, then can just say use of neuromuscular blockade. You can monitor it intraoperatively by monitoring the neuromuscular function. And any residual blockade after the completion of surgery, you can diagnose it with the easier method by using the nerve stimulator, which will prevent the complications of residual motor blockade. And you can decide about the antagonism dosage and injection time to optimize the reversal. And the methods of neuromuscular monitoring, you can first classify them into clinical tests consisting of evaluation of respiratory parameters, muscle function, that is 5 seconds head lift and hand grip. Then you can classify them into qualitative evaluation, which employs peripheral nerve stimulation and assess visually as well as tactilely the response of the stimulated muscle. So the standard peripheral nerve stimulation provide various patterns of stimulation, which are train of 4, double burst, tetanic and post-tetanic count to evaluate the various degrees of blockade as well as recovery. And they can draw these pictures to show what is the, instead of writing long sentences, you can just draw these pictures to show your knowledge on what is, how the various patterns of stimulation are applied and what will be the effect if there is a motor blockade and if there is no motor blockade. And this is another way of putting in the same thing, comparing between non-depolarizing and depolarizing block, which all can be done in a faster way. And for those who have not seen a stimulator, this is the peripheral nerve stimulator with the various functions marked here. You can see the twitch, single twitch, train of 4, tetanic, and double burst. All these things are present in this. And this is another simplified form of the muscle relaxation with lesser functions, just having a single twitch and double burst stimulation and tetanic stimulation. And the third type of classification is quantitative monitoring, use of neuromuscular monitor that stimulate the peripheral nerves according that. So there are almost about 6 types which are used, of which the mechanomyograph is considered as a gold standard, but it's a big machine which is used mainly in the laboratory. And advantages and disadvantages, limitations are all given in this chart. Then you have what is called electromyography, acceleromyography, kinemyography. How to use all these things she described very well. And you have phonomyography and compression myography. So there are 6 types of monitoring which are available for quantitative measurement. And the nerves that are commonly stimulated are ulnar nerve, facial nerve, and posterior tibial nerve. And the sural nerve, actually it is a sensory nerve. So I think this is a mistake here. So you have to use a motor nerve to see this response. Sural nerve is the right, and the response to the stimulation occurs by thumb adduction here and twitching of eyelid and eyebrow muscles and plantar flexion of the great toe. That is what will happen if you stimulate that. And these are the pictures of various types of this quantitative measurement and how they are applied for electromyography, kino, phono, and acceleromyography and mechanomyography. And this is a recent advance in that, which is using along with the blood pressure cuff to have a nerve stimulator attached to that. So a device that incorporates objective monitoring within the blood pressure cuff has recently been developed. And it's also referred to as modified cuff technique, cuff-based monitoring, which is a modified form of compression myography. New different monitoring modality that showed initial interest, and you can see the stimulus that is happening in the monitor, which is coming along with the multi-parameter monitor. Okay, so that is the short form of mentioning about neuromuscular monitoring, which is a very common question, and its answers are available in all standard textbooks, and you can easily answer that question. You should be able to